Today, you're going to start working on the Unit 3 review. I'm not sure if you noticed in the weekly schedule that I made a note that we will have the Unit 3 tests during the final exam schedule date. So we don't have a final. It's not going to be a comprehensive test. It's just going to be over Unit 3. So I just wanted to let you all know when the Unit 3 test was and what we were going to be doing during that final week. So the final times have been posted. So actually, B Day, you start testing first for your Unit 3 test. So B Day starts with the 5th and 7th hour final on Thursday, January 7th. And then A Day will start with their 5th and 7th hour final. Again, we just will be taking the Unit 3 test in place of the final. So that means that your unit review for B Day is due January 5th, this review here. And A Day, your review will be due January 6th. That way, we have time to go over it and you can ask me all the questions that you need to ask. The first thing I want to point out is you definitely need to take some time to look at these terms and the scientists and their experiments. This final is mainly going to be a big chunk of it is going to be a multiple choice true false type of test. I said final, but I meant test. So it's almost kind of like a history test. So you definitely need to study all of these terms. You do have a very short written or free response that I call it, but you definitely need to make sure that you focus on all of this here, okay? And all of these people. So don't ignore that page. This page will also kind of help you a little bit in studying some of those terms, but do not rely on this page to strictly get you into the frame of mind. That handout that I gave you with the models of the atom, that's going to be your best one to look at, where you added the little notes next to the 5 pictures of the atoms. That's going to be your best handout there to study over all of the scientists and kind of jot down or make some notes and their experiments on. And then as we go down here further, it's pretty self-explanatory. I will tell you some of these here get a little confusing, so don't spend too much time getting too tripped up or over analyzing what you're trying to fill in. Down here, you're going to need your periodic table to help you with writing the symbol and answering about the subatomic particle that you're looking for. Again, 10 and 11, you're going to use your periodic table to help you write down the name of the element. And 11 is going to it says if you only know the following information, you can always determine what the element is, and you're going to either write yes or no based on your knowledge about the subatomic particles. What I kind of want to take a look at is going to be this table here, and I wanted to work a few of them out with you, so that way you kind of knew where you were going with this particular table. So the first column is where you're going to write the hyphenated name or notation. So remember, that's where you're going to write the element symbol or name, then a hyphen, and the mass is going to follow behind it. Okay. So for instance, our first element for A is sodium. So you definitely want to have your periodic table out for this. And let's change the color so it kind of jumps out a little bit more at you. Make this font a little bit bigger. So we have sodium dash and then the mass. So remember, you go to the periodic table and you look up the mass. You will not have any isotopes that you're going to work with in this table, because the mass number you have to look up. You're not given any of the mass numbers. Isotopes. Remember, isotope is where your atomic number stays the same, but it's your mass that's going to vary. And this number is going to reflect that isotope's mass. And remember, the mass that you're given may not be the mass that appears on the periodic table for that particular element. The isotope that is most common or has the highest probability or percent abundance is the isotope that is on the periodic table. That's really important. If you're looking back at some of the vocabulary in that first page, here's one of your answers. So again, the isotope for your element that is most common or has the greatest abundance is the one that's on the periodic table. So again, when you're looking at some of these, especially up above this table, your mass may not correlate to the mass that's on the periodic table. That's a sign that you're working with an isotope. What's going to be different would be your number of neutrons. Is your number of neutrons that's going to be affecting or your mass, or realizing that you're working with an isotope. So hopefully that clears up some of those questions about what is an isotope. So we have sodium 23, our element symbol for sodium is Na. So when you're writing your element symbols, please make sure, or typing, that I can tell that they're uppercase and lowercase when necessary. Your atomic number is your whole number on the periodic table. So sodium has the atomic number 1. We're going to round the mass to 23. Remember, your number of protons is the same as your atomic number. So we're going to put 11 here. Since there was not a charge wrote right here, we're going to put $11. So we're working with an atom. So remember, with an atom, your proton number and your electron number will be the same. Our number of neutrons. Remember, to find your number of neutrons, you're going to take your mass number minus your atomic number. So 23, and I'm just going to make this over here, 23 minus 11 is going to give you your number of neutrons, or 12. You don't have to put this work in here. I'm just putting this here. There we go. 23 minus 11 gives you 12. So you don't have to put your work here, mass number minus atomic number, to get your number of neutrons. And then you're going to write your element symbol. And notice it says it wants the nuclear or the complete element symbol. So with this one, you're going to write your element symbol. And then your mass rounded is always going to go in that upper left-hand corner. And your atomic number will always go in the lower left-hand corner. And since our protons and electrons were the same, we don't have to worry about a charge. If there was a charge, it would go right here. Okay, so let's take a look at letter B. So with letter B, we're not given an element symbol. So we're going to have to go to our atomic number at this point to determine what the element is. So go to your periodic table and look up the element that has the atomic number 17, and that's chlorine. So we're going to write or type the element symbol, capitalize C, lowercase l. And I'm going to write the hyphenated names. So chlorine dash, and then the mass is going to follow it. So chlorine has the mass of 35. The mass is 35.4, so we're going to round that to 35. And so over here, the mass is 35 because we round that. Our number of protons is going to be your atomic number, which is 17. Ooh, notice your electron number and your proton number are not the same. So this is a sign that we're working with an ion. Remember, an ion is where your number of protons and electrons are not equal. So your atom has a charge, either a positive or a negative charge. So that's going to be reflected in your chemical symbol over here. So to find your number of neutrons, we're going to take your mass number, which is 35, minus your atomic number, which is 17. And that's going to give you your number of neutrons, which is 18. And then we're going to write our complete or nuclear symbol. So our element symbol is Cl. Our mass is 35, so that's going to go in the upper left-hand corner. Your atomic number goes in the lower left-hand corner, or your number of protons. Now, to figure out your charge, you need to focus on your protons and your electron number. So what's the difference? The difference is 1. What do you have more of? Positive protons or negative electrons? Negative electrons. So that means that your charge is going to be a -1 charge. If you had a positive charge, remember you have to write the plus sign. It's just like a math class, we assume it's a positive number and you don't have to write the charge. But when you're writing ions, you have to write the plus sign. And does it matter if you would write a 1? No, this is understood to be a 1. And it doesn't matter if you write the numerical charge and then the number, or positive, negative first. It doesn't matter. Whichever one it doesn't matter. It's not set in stone. So let's look at one more here, just to make sure that you're good to go. This time we're working with potassium 39. So potassium has the element symbol K. It has the atomic number 19. So that means your number of protons will be 19. And since we're not given our number of electrons and this symbol doesn't have a positive or negative with it, we're going to assume that our number of electrons are the same. So we have 19. Find your mass of potassium. Well, I gave you the mass number of 39, or you could look at it on the periodic table. Now, to find your number of neutrons, we're going to take your mass number, which is 39, minus your atomic number, which is 19, and that's going to give you 20 neutrons. And then we're going to write our complete or nuclear symbol. So we have a K. The mass is going to go in the upper left corner. Your atomic number is going to go in your lower left corner. And since our protons and our electrons are the same, we don't have a charge. And again, that's where your charge would go. So if you could go on and finish completing this chart for me.